All right, Murray Campbell, Centipede final sprint report, take 521. Action! Hi, it's Murray here. It's your boy. It's been a long quarter. We've seen some pretty intense stuff. Uh, we've lost a few along the way, but here we are at the end of 10 weeks, stronger than ever, with a few battle scars of our own to share with our friends and family. Now, I'm gonna run through this whole project. It's gonna take a long time, um, but I'm gonna try and do it as quickly as possible because I'm hungry, I'm tired, and I just want to be done with Centipede. So let's begin. I'm gonna start by opening this game and letting attract mode run for a little bit while I talk about what's in the game and what is not in the game. Okay, so here we have Centipede. Right off the bat, I can just tell you about all of the UI stuff that we got. We have like the player score on the left, the top left, the high score on the middle, and you'll see that working in when I actually go into play mode. But this is just the attract mode. We have the high score list that has all the high scores and gets updated. I'll talk more about that later and some issues that I had with it. But for now, that's visible right there. Right now, you can see the centipede, centipede working. You got the spider right there. The track mode hasn't beaten this first wave yet, so I'll have to actually play it to show you the other critters, but these critters are working. Let's see, we only have single player, no second player. Okay, let me actually start playing this now, so I can show you the other stuff. I'm gonna press 1 and turn off the sound. There we go. Okay. So we got all of this stuff. You got player movement, player shooting, only one bullet on screen. Got the spider, got the centipede. Ah, shit. Okay. Got mushrooms, got the 4 health on the mushrooms. They get destroyed. All that good stuff. I got the life marker up there. And we got wave changing. See, we got the flea and the scorpion just came in there. Oh, that's weird. Yeah, so I'll talk about my centipede and what's wrong with it in a bit, because it just should have done something that it didn't. But that's all good. Let's see what else. Got the VFX, like the explosion of the spider into the score text, and that's all good. Oh, I'll show you. Oh, also the flea and the scorpion have working sounds. I just don't have the sound on right now because that would suck. So I'm gonna die here so that it goes back to the main screen. You see, I've beaten the high score, and you can see that my score is up there now. Okay, yeah. I guess it also put all of the the attract mode scores in there while I was playing. So yeah, that the high score list will be updated while you're playing. And I'll talk more about what I didn't do with that later. But that's all in there. Let's see. Is there anything that I need to show in the actual game itself? No. looks like that's okay for now. I mean, you can pretty much see everything that's there. Um, so let's start talking about the code. The big kahuna. The code. Alright. Where should I start? I'm not going to start on the class diagram. I'm actually going to go over to here and basically read through this list and tell you what's in the game and what is not in the game, right? So I have the blaster, the player or whatever, has the sounds, the movement, death, all of that, single bullet at a time. You saw in attractor mode, I had a basic AI. I had keyboard controls for it. The AI for the player is not exactly like the AI in the IGN game or in the Flash game that we used for reference, but it goes left and right and shoots every so often, and that's all I had time to implement. But it works, it's fine, and it's implemented correctly with the correct patterns. And I'll talk more about that later. We got the mushrooms. The mushrooms have sounds. The mushrooms don't really have sounds. I guess it's just like when when you hit a mushroom, it doesn't make a sound. There's the poison state. We got regeneration at the end of at the end of whenever the player dies. So let me talk about that. That doesn't actually happen like it does in the Flash game in my game. I didn't get the chance to actually stop the game, to implement the whole stopping the game, counting through everything, doing a and counting up the score from the mushrooms. But it does do that calculation. It adds it to the score and it regenerates all of the mushrooms. It's just instantaneous, and that sucks. But I had to do that. Let's see. Okay. The centipede is implemented completely. It has the sounds, the movement, and the death. That all works correctly. The turns are not actually smooth rotational turns, but they look damn close to it because when the centipede needs to turn, it actually just turns and looks down, goes down one, and then turns the direction that it needs to go. So it is. It is rotating, but it's just doing it at 90-degree increments, right? So it looks fine, looks great, but it's not that smooth turning, right? That the smoothest it could be, right? It turns at mushrooms, ignores some mushrooms. There's something in my centipede that just when it turns, it doesn't recognize. It doesn't decide to turn right away after it gets to the lowest point of its turn. And that's been in the game since I implemented the centipede, and I just haven't fixed it. So that's just in there, and that causes a few problems like the one that we saw earlier. But yeah, there's that. I guess I wasn't able to show it in the actual game, but when the centipede gets to the bottom, it actually will stay in the bottom rows. What else? When you hit a segment, it does split into a new head. And when the head hits a poison mushroom, it will drop to the bottom of the screen. That's implemented. That's all good. Let's see. The scorpion has its sounds, movements, and death. It poisons mushrooms. That all works. That's fine. The flea has its sounds, movement, and death. It also has 2 lives and drops faster after 1 hit. That's in there. The spider is fully implemented. The distance is calculated, and you saw the effect there. That looks good. That's great. What else? Okay, I have both the attract mode and play mode. The attract mode displays the high scores. That's good. The game runs normally. The characters do block the centipede. You saw that. Oh, but all the sounds are off. And then you go into play mode. The sounds are on. The high score text is gone. Only 1 player. You get 3 lives. That's shown in the UI. in the HUD, right? Um, then there's waves that it reads from a text file. That's all implemented. Let's see. So on death, if the high score is reached, it just enters the three letters YOU instead of letting the player do their own name. I didn't get the chance to halt the game and do that high score entry stuff. That would have taken way too long, and I wouldn't have finished this in time. So that I had to cut, but it's the high score system still works. Otherwise, another thing about my yeah. So another thing about my high score system is that it is not based on a text file. There's no I didn't get the chance to implement any text file input or output. So that's not implemented. I just have a basically an array of high scores that it populates and like at the start of the game, and it persists as long as you play the game. But as soon as you leave, it'll reset. So that's not ideal, but it's still a high score system, and it works, and it's fine for me. Let's see. Scoring points implemented as specified in the info page of the game. Yeah, that's all good. All the points work. The HUD works. HUD's in there. All right. So I don't really need to go into. Oh, okay. I guess I can go through this and talk about each. So let's see. Use the strategy pattern. Yeah, the command pattern or whatever. The blaster. Actually, I might as well just go through my classes and explain how each of them works, rather than go through this at this point. So I'm gonna do that. Hang on. Yeah. Okay. Well, actually, no. Some of these I will need to go into code, and I'll just I'll do that. But let's see. I must mention that so I use the command pattern throughout throughout this project. That's used liberally. Observer pattern is like probably the most prevalent pattern in my whole system. My game really relies on objects having references to other objects, right? And it's really cool. Like that pattern is so useful. So that was like a really awesome thing to learn this quarter. Let's see, the factory pattern. I've been like the factory pattern implementations have been on my back burner for this entire project. I only got the chance to implement a factory pattern for my mushroom, and that works, and that's good. It's a singleton, and it's great. But none of the critters have factories, and none of that works. So it's like really it's inefficient, but that's just like time priorities that I did not delegate. I use the single pattern quite a bit, the singleton pattern, and I'll show that when I show you my class diagram. Let's see. Let me just check. This is good. Okay, so yeah, the centipede head and body are subclass from a base centipede class. They have a linked movement. They have references to their next and previous in the line of the centipede. I'll explain that more in depth in a bit. Let's see, mushroom field housekeeping. Yeah, so I'll talk about my grid manager soon, and that's probably like among the traffic cop implementation for the centipede. that and my grid manager are two of my, I guess, like the things in my project that I'm most proud of, that I put the most work into and ended up being like the most useful aspects of this whole project. So I'll go into that. My mushroom field, I think, is like pretty awesome. But it might be a bit bloated. Who knows? So let's see. The wave control, I'll talk. I have a wave manager that handles all of this really nicely. It's huge, but a lot of things rely on it, so it needed to have a lot of functions in it, right? Player combines the state of the mushroom field, score, life, wave. Yeah, I don't know what that means, but yeah, my player works. The text display is implemented via flywave pattern. That's all good. Everything with text is great. You saw that in the when I showed the game. Let's see, sound manager. Yeah, I have a singleton sound manager. That can modify the global sound volume of all of the sounds. It can toggle a mute and it can play each and every sound in the game. And so if anything needs to play a sound in this game, it uses the sound manager and calls whatever sound it needs, and the sound manager just plays the sound, right? All of the Yeah, it's all good. I'll show that in a second, and I think I did a pretty good job with that. Let's see, high score manager, have that. I explained that earlier. I'll show that in a second. Okay, and then code practices, you'll see for yourself. I'm like aware of. I'm only so aware of my coding efficiency and structure, so that will really be up to you to figure out like what's good and what's not good. I really hope that if there is any issues with how I structure things, that you let me know, because I really want to improve in this, and I really want to make sure that my code is like as readable and as efficient as possible, because that's like super crucial, right? So yeah, I can get out of this, and we can jump into this big hulking system game thing. Okay, let's see. So I'm gonna start by showing my singletons, and then I'm gonna dive into the beef of the program through the grid manager and the wave manager, right? Okay, so on the right here, I have different singletons. I got a struct that I've got structs and enums that the score manager uses. These are singletons. Okay, so score manager. Score manager is a singleton. It carries with it two structures. One is an enum called score value that holds all of the values for scores as ints. The other has a struct called high score that has a name and a score. And then I use that struct in the actual score manager class as a high scores list, and this is my list of high scores that I was talking about earlier. Let me just show you scoremanager.cpp for a second. I populated in the beginning with just these default variables, right? That's all good. I have a set score, set high score, all of that's fine. So there's that. There's the score manager. Oh, wait. Okay. So then there's the sound manager. This is huge. I've got this toggle. It's a singleton. I've got this toggle mute thing that will change all the volumes to it calls this set global volume to 0, and then does some other logic there. Like in the constructor of the sound manager, I get all of these sounds that these are good. They're acquired, and they persist throughout the program. And then I have all of these play sound things that are no logic whatsoever, just playing the sounds, and that's all I need to do. I set whether or not something is looping, if it needs to loop, and then I handle everything else outside of the singleton, and that's good. All right, let me talk about the Mushroom Factory. This is pretty basic. It's a singleton, has create, recycle, all of that good stuff. That's fine. Movement arrays. This is what I use. Oh man. Okay. Yeah, I'm actually going to talk about movement arrays when I talk about the centipede, because the centipede, that's what the centipede uses. I have the sprite sheet, glyph, font classes. I don't really need to show them. Yeah, they're yours. These are all good. I use these in my grid manager to do the HUD, and that's all good. The grid manager is what handles the HUD, because the grid has positional data of the entire grid, and I can just basically like put it in a grid space in that grid array, right? You know about this, but let's like go into the grid manager now, and begin our deconstruction of this entire freaking game. So my grid manager, my freaking holy grail, this thing has been incredible. I'm so glad that I made this in the beginning and leveraged it for everything, because I have heard of the horrors that some people have gone through who did not have a set grid manager class and handle everything by just like calculating stuff in the grid. It just seems like something that I don't want at all. I enjoy structure, so I set up the structure of a grid. This is like I made a grid based movement game a while ago, so I had a similar system to this that I just thought would do well in this project. So the moment I started this and realized that we were going to be using a grid, I was like, okay, so I need to have a struct called grid space that has whatever fields are possible that I need for a specific space in the grid. It's like a position on the screen, like in this game, a mushroom, because there are a lot of mushrooms in this game, so it need like things like the centipede or the flea need to know whether or not there's a mushroom in a grid space. Honestly, I could have saved some space here and just had a bool for has mushroom, because you'd never need to like do anything to the mushrooms in the grid space as far as I know. I might have something in there, so that's why I have it, but I might have been able to just use a bool like has mushroom and call that, and that would have saved some space. But you know, and then I have a bool for has text that the centipede calls. The centipede uses in its check to see whether or not it should turn, right? I have this dimension struct. This is just like what I use to divide the screen into grid spaces. So I take the grid. Yeah, I take the window size and I divide it by these widths and heights, right? And I do some offsetting, and that all works, and that's good. I populate that. So I have this. This really should be private and be accessed, but I didn't get to that. But I have a 2D array called grid. It is a two-dimensional array of grid spaces. This struct right here. That is, the dimensions, right? And at the beginning of a game, the grid manager will populate these. It'll do a random check to populate it with a mushroom, and it'll set up the score. It'll set up all of the HUD stuff here. That's all good. Yeah, so basically, yeah, a lot of my classes have like through like by observer pattern, they have a reference to this grid. You can kind of see that I passed this into the mushroom factory, for example, because the mushroom has an idea, knows the grid that it comes from, right? So it has a field in there called parent grid, right? Okay. Anything else super important here? Are we on time for 25 minutes? Okay. Yeah, this is going to be long. Yeah, this was not ideal. I have the HUD stuff here is, I just have the font. I have like a glyph list for every single unit of text that I need, right? And by unit I mean it can be like a string of different characters, so it can be more than one. It's not just like a single unit, but yeah, like the first score, second score, all of that, and it populates those when it sets up the grid, sets up the attract mode. Like it's all of this stuff here, huge thing. So yeah, what else do I need to show? That's pretty much it. Let's talk. Okay, so the grid manager, you can see the mushroom uses that. Maybe we can just talk about the mushroom. It's got the health, all of that, poisonous. That's, yeah, it's fine. This is all good. I just want to talk about larger structures that things leverage rather than go into each and everything and say what specific things they're doing. And I just want to highlight the most important stuff. All right. So, Jesus, let's talk about the wave manager now. Okay. So, I have some file file output or whatever. Let's see. In the beginning, it will it just reads this wave file. I have a text file that it reads from. That's all set up correctly. It's how you want it. I even have support for empty lines, just for like these aren't necessary. It's safe, but just for, if you want to have some organization in the wave file. And so you set up each of these values, do true or false, all of that. That's good. So this is where I'm reading it. Nothing super special here. So the wave manager is, in a weird way, my big factory as well. And it's not actually a factory because it doesn't do all of the cool stuff that factories do, like recycling. But it handles the creation and has callbacks for certain things dying or certain things happening in the game. My game leverages this almost as much as the grid manager does. That's why a lot of my classes, such as the player, actually that's not a good example. But like some of my critters will have in their constructors parameters for the wave, a parent wave manager and a parent grid manager, because I use both. How I manage the one critter on a screen at a time is I have a pointer reference to a singular spider that when it goes off screen, that'll get destroyed, and if it runs its check and it doesn't, and there's no spider, it'll like respawn it or whatever. Here, I'll just here. Let me actually explain how this works. So this is a game object, and it has, because I use update to run checks to see whether or not it should spawn certain things, or check to see if the wave is completed, right? But I didn't want it running these checks 60 times a second, because that would be a ridiculous amount of computing and ifs that was like unnecessary, because it doesn't, like, the game doesn't have to be instantaneous like that, right? So I have a timer that will run the check once a second, once every second rather than 60 times a second. So every second it'll check to see if the centipede is completely killed, and it increments the waves how it should. It spawns things, all of that, right? Oh, this is also where I handled the centipede sound stuff. So, that's also a timer, because it's just like do. The sound is like do. So I need to make the sound go do 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 do, and I could have looped it, but oh yeah, I tried looping it, but it was way too fast. So I just like did it on a timer, and when it gets to a certain amount of, like, a certain time, it'll do that, and it only makes that sound when there's a centipede head on the screen. How I like handle all my centipede head stuff. This stuff is cool. I'm proud of this. I have a vector of centipede head pointers called centipede heads. Why a vector, you ask? Well, a vector affords me with some cool stuff that I can use to, like, push stuff at the back of a vector. It's like a stack or a queue or whatever, but with some extra features that I needed. Pushing at any index, or searching for a certain... this might have been equally achievable with a stack or a queue. I don't know, but I decided to do it with a vector. Partly because I also wanted to learn about vectors, because I've never used them, and otherwise I would never have had an opportunity to use them in this project. So I have some functions that help me add a head to that vector. It pushes it to the back. Then I use this awesome erase remove thing that I looked up and figured out. Look at all this work. I tried so hard to figure out how to remove a specific head from this vector, because this vector is what the wave manager uses to check whether or not it should spawn a centipede or increment the wave, right? So it needs to know exactly how many centipede heads are on the screen, as well as how many bodies. So I have a counter for the bodies and a vector for the heads, because because I need that vector for the heads so that I can iterate through it and tell each head to destroy itself if the player is killed. Because when the player is killed, everything it gets destroyed and the wave restarts. So this was super important, right? So yeah, and don't mind that, but I use this erase remove thing. I forgot the exact term for it. It had a special term, and I would have sounded so smart if I knew it. But yeah, then I shrink it to fit, and that's all good. I don't have to worry about it at all. It's all good. This is the function where I tell the centipede to kill itself. As in, like, this is where I tell the game to kill all of the centipede heads and bodies that are on the screen. So, it's a while loop, and while this vector is not empty, it will go through each and every centipede head in the vector, call this function destroy centipede, which is in the centipede head function, that is a recursive function that goes through all the way to the back of the body, like the bodies, um, and destroys each body one by one, and then destroys the head. Um, Subtracts from the body count, it's all good. Then we pop that back, strength fit, all good, it's clear. Yeah, I have these spawning and killing functions. So all of my actual like marking for destroy and whatnot, for each of my critters and the player and stuff is handled here in the wave manager. I needed that because I used the sound manager here. It was just a way to centralize the creation and destruction of all of my stuff rather than handling it in the actual classes themselves, which are temporary, whereas the wave manager is persistent, but it's not a singleton. But anyways, that was good. So I just have these functions that kill spiders, set the spider pointer to null, do like anything extra that it needs to. That's all good. Here I have this player killed, so when the player is killed, you get this callback, and it destroys the player, plays the death sound, does all of that, kills everything on the screen, and then checks whether or not you have lives. There are lives in this game, in my game. If you're out of lives, it goes back to the attract mode, and that's all good. I also have this spider score value thing, that will take the position of the player and the spider, calculate the distance, just the Y distance, and that's all I need, and it's good. Spider far, yeah, we're good. Oh man, I'm starting to lose the ability to speak. So I'm going to try and do what I can to make this quick. Let's see. Player, I have a command pattern. Let's talk about the player for a second. The player has a reference to the bullet, and it handles an observer relationship with that. And the one bullet on the screen is handled in the player and the bullet simultaneously. That's all good. I have a command pattern for the player controller. I have a base player controller class, and then a player controller for the attract mode, and a player controller for play mode. And these work how you expect them to. Let's see. Spider. The spider has a spider controller because the spider's movement is a little complex. So in the spider controller, I've got some. I actually use my knowledge from the centipede to engineer this. Has a timer. When it gets to its max time, it'll make a decision. It'll determine where it wants to go next, and then it'll move to that position. Also, it does the callback for whether or not the spider is off screen and needs to be destroyed. Is here. If it's off the screen, this is really long. It's a long if, but yeah, that's what happens when the spider's off screen. Let's see, centipede. The centipede base class, and then the centipede head and body subclasses. All right. I want to leave this for last, actually. Because it's my crown jewel. My terrible crown jewel. God, I'm so bad. Okay, no, I'll talk about I'm fine with self-esteem. Totally fine, but I got some words to say at the end of this about how beneficial this class has been for my knowledge of what I have to learn and all of that. But anyways, Flea works how it is. Flea actually works similarly to the spider and the centipede, it has decision making. It makes a decision after a certain amount of time. Um, but it doesn't have any command pattern because it's not that complex. It's not like I was just like, oh, it's gonna take a long time to, or an unnecessary amount of time to implement a command pattern for this. Why don't I just handle it in one class? Because all it does is it goes down, and every time, like, goes straight down, and every time it gets to a specific grid position, a new grid position, it checks to see if there's a mushroom there. Let me actually show that. Checks to see if there's a mushroom there. And if there is no mushroom there, then it rolls like a random. It rolls the dice, and sees whether, and then it will spawn mushroom. Right. That's good. That's how that works. It's good. Let's see. Scorpion. Man, I can't believe I've gone through like all of this already. I should mention also that I have the play mode and attract mode as separate scenes. That's all good. The scene system was fun. It's so easy to switch between scenes. It's crazy. You just like call like change scene and then it's done and you don't have to worry about anything. It's freaking great. Let's see. Scorpion is not complex either. In fact, it's less complex than the flea because it doesn't even have to check the freaking grid. But it does need to check the grid to get a good starting position, that sort of thing. So that's why I needed a reference there. Oh, let me actually show how this works. So I have a field, a reference to the parent grid and the parent wave manager, and when these are created, in the wave manager will pass itself into the wave manager position, and the wave manager has a reference to the grid manager, right? And it uses that and passes that through the wave manager into that new class that it's creating. And that's how that works. And that's how the hierarchy works. But so the grid manager is technically at the top of everything. It is my the king. So that's my system. And knowing how like useful that the grid manager is, I'm glad it's at the top. Me and my grid manager, we are best friends. It's been a great quarter together. I will never forget the memories that we had working on Centipede together. Me and my grid manager. Oh no, that's not what I wanted. Nice. This is good. Intermission. How's everyone doing? Okay. Back to business. Alright, let's take a look here. Where are we at? Damn, 43 minutes. I'm sorry. Wow, this is so long. Okay, we're like closing in on the end here. Okay. Centipede. The crown jewel, right? Centipede, the base class. The base class of the Centipede handles, what the F does it handle? Yeah, I mean, it handles its references, handles its position, all that good stuff, and it has these generic, or these functions that either of the classes can call, either of the subclass, like any subclass can call, such as destroy a body, and this function is actually called in the head as well. It's not just bodies, but it works for both. Yeah, that works. Then I have a function called spawn bodies. It's a recursive function, and it will spawn the bodies behind it recursively. It's good. Then I have this destroy all bodies thing. That is also a recursive function that is called in the wave manager. You know how I said the vector a while ago. So yeah, this is recursive. Does stuff. It like tells things to die. basically handles it correctly. All that good stuff. Let's talk about the body. Body's cool. Body handles the sprite stuff, as well as references to a cop. We'll talk about the cop and the Senate and the controller in a second. So I just need to explain that entire system on its own. Let's see. Centipede body. Centipede head handles its own sprite stuff as a reference to a controller. Now, let's talk about Centipede movement. The 5-week project of this project that made me feel bad and also made me learn a lot. Let us begin. So, I came up with the traffic cop system for the Centipede, which is the best system in the world. If you think queues are good, well, you got another thing coming, because the traffic cop system is here to kick your butt, and it's amazing. I don't even need to say why. Alright, so unfortunately, as the inventor of the traffic cop system, I had the hardest time implementing it. It sucked. I don't know why I struggled with it so much. I struggled with the Centipede for way too long. Honestly. But me and the Centipede got real close. Not as close as I am to the Grid Manager, though. But anyways, here we have my Centipede movement system. It starts with the movement arrays singleton. This is a singleton that at the beginning that calculates arrays, movement arrays. It calculates arrays of offsets. And these offsets are awesome. These it's basically what each controller or cop uses. It will just, like, the centipede controller or cop will call the movement arrays stuff. It'll basically just, like, take the array and add those offset values in a for loop to the centipede, and those offset values are calculated. If I want to do the speed of the centipede, there it is. I just put a number in for num steps, and it like divides it here. It's all good. We are great. It's and that's what that there's the offsets, right? So it just populates all these arrays with offsets. And these are vectors, vector twos, all good. So let's talk about the cop. Okay, no. Well, I need to talk about both the cop and the centipede controller. So here we go. This is the centipede head. Every centipede head has a controller, a centipede controller attached to it. The centipede controller is what handles all of the decision making for the entire centipede behind it. So the centipede controller looks like the spider, and the whatever else has this. I have a timer that increments. Wait. What? No ways. Wait. I totally forgot about this. I'm great! This doesn't use a timer at all. It's awesome. But it still has one if. You see, it's got these two ifs here. So let's see. It'll go through. This is, yeah, you see here. It calls the movement arrays. It accesses the You see, okay, here. This is how the centipede moves. Boom, right there. It literally calls its movement array, that the movement array that it needs, and it has a reference to a specific movement array. It's a pointer, right? And that is determined, and it changes when it needs to, and then it just adds that with the index to the position, and that's all I need to do, and it's great. That is genius. Anyways, I couldn't have gotten to this without the help of Andre and Mariah and John, because they're great, and yeah. Yeah, this was hard to figure out, especially for me. I had a really hard time with this. Let's see. So, when it reaches the end of the movement array, then it increments that index. When it reaches the end of it, it determines where to go next. And that's all here. This beautiful function. That sucks. But this basically does all of its checking, all of the logic, and it's all handled here. This is the big computational section of this whole game. And then after that, it'll update its positions accordingly. So the centipede controller does all the decision making, makes this decision, also makes the head move, but on top of that, it passes a cop. It creates a traffic cop that it creates a traffic cop that the next cop in line. Here, I'll go to head call create cop. Call create cop. It calls create cop in the body. Right here. So it goes all the way through. It tells the prev to create a cop. This is the only place where a cop is created, is by the head. The head creates the cops. The cops stay alive until there's no bodies to tell what to do, and then it destroys themselves. That's how the traffic cop works. The cop will tell the bodies what to do, and the cop just has it has the final position. When the cop is created, let's see, the cop needs the movement array, the final position, so that it can just update that as well, and the final grid position, and a rotation. That's all it needs. And it just does the same thing that the centipede controller does, and when it reaches the end of the movement array, it will pass that cop down, passes the cop down to the next body. Otherwise, if there's no next body, it dies. And that's great. It does other things like rotating, setting the position, all that good stuff. Real good. There's that. Basically the cops are only handled by the centipede body, and the centipede controller belongs to the head. Every centipede has references to the next and previous in the line, all that's all good. Traffic cop system good, implemented, we're golden. So that's that's pretty much it. I'm pretty sure. Yeah, I've showed you everything. Showed you all my command patterns, all my stuff. That's it. This is my centipede project. Thank you for listening. It has been an hour, nearly. I hope you are not tearing your face off right now. Okay. Bye. Thank you for everything, Andre.